This video goes over question 8 of the chain rule assignment. Find f prime of x and find the equation of the tangent line to the graph of f at the indicated value of x. And third thing is find the value of x where the tangent line is horizontal. So I've got x or 10x minus 4 all to the 1/2 power, and I want that tangent line where x equals 2. So I'm going to write out the chain rule. If y equals f at u, y prime equals f prime at u times u prime. My u here is the linear 10x minus 4, so u prime is just 10. To get the derivative f prime of x, I'm going to do the power rule on the parenthesis like it's just a variable, so 1/2 10x minus 4, and I need to reduce that or subtract 1 from that old exponent, negative 1/2, then multiply times the derivative of the inside u. So that's times 10, and then I'm going to rewrite that as a fraction because it's easier to evaluate that way when I need to get the derivative at x equals 2. So 10 divided by 2 is 5. 5 times 10x minus 4 to the negative 1/2. And then I'm going to rewrite it as 5 over 10x minus 4 to the positive 1/2. And then even rewrite that as a radical notation of square root 10x minus 4. And I need my slope at x equals 2. So f prime at 2 is 5 divided by 10 times 2 minus 4. That's 20 minus 4 is 16. So the square root of 16 is 4. So my slope is 5/4. And I'm going to use the point slope form to get my tangent line. I'm going to write that down. Y minus y1 equals m times x minus x1. I do have an x1. x1 is 2 because that's what the book gave me, and I need a y1. I'm going to find that by evaluating the original function at x equals 1, or x equals 2. So that's going to be 20 minus 4 to the 1/2 power, which is also going to be 16 to the 1/2, which is 4. So my point is 2, 4. Using the point slope form, I get y minus 4 equals 5/4 times parenthesis x minus 2. Now, I would take that as a perfectly good answer, but the book wants y by itself. So we'll go ahead and put this in slope-intercept form. Y minus 4 equals 5/4 x. And then this is going to give me minus the 2 and the 4 will cancel to a 1/2, so minus 5/2. This is 8/2, so y equals 5/4 x plus 3/2. And I just realized I haven't put in my derivative, so we need to go back and put that in. So fraction 5 divided by the square root of 10x minus 4. Check answer, good job. And then going back and checking my tangent line, y equals 5/4 x plus 3/2. Fraction 5 over 4 times x plus fraction 3 over 2. Check answer, good job. Now it says, select the correct choice below and fill in any answer boxes in your choice. The tangent line is horizontal at x equals, use a comma to separate answers as needed, where the tangent line is never horizontal. This is another advantage of using this square root in the fraction notation. The derivative gives me the slope of the function. For me to have a horizontal tangent line, this derivative has to equal 0. The only way a fraction can equal 0 is for the numerator to equal 0. The numerator here is just a constant 5. So this derivative can never equal 0. So the tangent line to this function is never horizontal. So we'll go put that final thing in. Check answer. Nice work. And I'm not going to go into the next question. I'm going to do the same thing in the calculator. Doc 412 to graph. And I'm going to put in parenthesis 10x minus 4. Get out of the parenthesis to the power of fraction 1/2. And you can see that this is a increasing function. The slope keeps going further and further down, but I'm never going to actually roll over to a horizontal tangent. Control doc for plus page, shift minus to get my derivative. X is the variable, tab to move through the template f1 of x. Okay, so it did this a little bit different, but it's going to be the same thing. They factored out a 2 down here. So it's, if we check it, equals fraction 5 over the square root of 10x minus 4, says it's true. So to get the slope at x equals 2, we grab the derivative such that x equals 2. 5/4 is what we thought. And then we want the original function at 2, so 2, 4. Menu 3 y minus 4 equals control divide for fraction 5/4. Get out of the fraction, parenthesis x minus 2. And then the only thing I need to do now is add 4 to both sides, so plus 4. And there's my tangent line, just like it is here. And we can also use menu, algebra, solve, go all the way back and get the derivative. So there's the derivative the way they did it. Set it equal to 0, solve for x. And it says it just doesn't happen. So the tangent line is never horizontal. And we did get the whole question right.